In this video, we're going to use a system of linear equations to solve an application problem. Well, actually, I'm just going to go as far as setting up the system of linear equations, and we'll stop short of solving, but we will want to get our system set up because that can often be a challenge. And that's really the trickiest part of application problems like these. You might recognize this problem as number 22 in your textbook. So whenever I'm solving an application problem that's going to involve a system of equations, I first notice that it's happening by looking here. When I read through this whole thing, we have Amanda invested a total of $2,200 into 3 separate accounts that pay those various percentages. Amanda has 3 times, and it tells us in details, so she has 3 times as much invested in the account that pays 9% as she does in the account that pays 6%. And the total interest for the year is $178, so how much did she invest at each rate? And to me, that's the key. I apologize, my pen was too small. That's the key. At each rate, there are 3 rates. We're trying to find all 3 of them. That means we have 3 variables. So for a lack of anything better to call them, we will let our variables just be x, y, and z. And so I will always start off by explicitly stating what they stand for. What do I mean? I'm not just going to call x the 6% account, because what quantity is that? The quantity is what I'm looking for. I want to make sure I know what quantity x stands for. It won't be a number, but it needs to be something that I can quantify. And so x will be, because what am I looking for? I'm looking for how much she invested at each rate. So x will be the amount invested at 6%. And then y and z will match the other 2 accounts, so it'll be basically the same thing. And then z will be the amount invested at 9%. And now we ask, what do we know? In most of these problems, one of the equations should jump out at us. There might be 2 or 3 that jump out at us, but at least one should. And the one that jumps out to me here is we invested a total of $2,200. Well, we invested that total, and the places where we invested it were the 6%, the 8%, and the 9% accounts. So if we add those together, if we add the amount invested at 6% plus the amount invested at 8 plus the amount invested at 9, we should get the total amount invested, which was $2,200. What else do we know? Well, the next sentence jumps out at me. It compares 2 accounts. We have 3 times as much invested in the account that pays 9% as in the account that pays 6. The problem is this equation can be a little tricky. So let's play with it off on the side here. The amount that pays 9%, or the account that pays 9%, has z dollars in it. And what this says is that z dollars is 3 times as much as the amount in 6%. So it is 3 times x. So why did I put it over here? Because when we put our equations into a system of equations, we really want them all in standard form. X, y, z equals constant. So I need to get everything to one side. I'm going to do that by subtracting the 3x over. So I'll have negative 3x, there's no y's, plus z equals, well, what am I left with if I subtract 3x? That's right, 0. You might have been able to jump straight to this one or say 3x minus z equals 0. Notice that would be the same thing. If we had 3x minus z equals 0, then all we've done is multiply this equation by a -1. And we can multiply any equation we want. As long as we do the same thing to both sides, we can multiply any equation we want by -1. So that's the same equation. Now what's the last one we get? Ooh, I see the word total again. See the word total, but this time it's total interest. That's $178. So we need to add up the interest. Well, how much interest would we earn in the 6% account? Obvious answer is 6%. Okay, but 6% of what? How much have we invested there? We've invested X dollars. So we earn 6% of whatever X is. Well, in order to do that, we're going to multiply X by 0.06. In order to find the interest from the 8% account, well, we'll multiply Y by 0.08. And we'll multiply Z by 0.09. And that sum should be $178. Pardon me. So now we have a system of equations that can solve for x, y, and z. Now, as I said, we've got a system, but we're not going to solve it here. I'm going to leave that as an exercise. However, to help you out, the solution to this system should be we invested, something's not quite right. Let's see. $200 at 6%, $1,400 at 8%, and $600 at 9%. So that's the way to set it up. The solution, the way to find the solution, we've shown in other videos, or you've seen on the PowerPoint. So I recommend giving it a try. You should end up with these answers. Thank you very much.